Hey, welcome to another video in my commercial service calculation crash course series. This time around we're going to be going over an office building and we will be in the 2020 NEC, but don't worry because this should be good for multiple code cycles going backward because they don't really change Article 220 all that much or all that often. I call this the crash course because I go quickly through this example. I do show you every step along the way, but if you are looking for more information, a more detailed approach, where I go into all the code articles and every reference, every bit of information you're going to need, I give it to you in my deep dive series. Please check that video out. I'll have a link either below or at the end of the video for sure. Okay, this is a table that I've developed and I'm going to go over it really quickly with you, show you how it works, and then we'll get into our example after this. So first of all, on the left-hand column, we got the square footage of our building. Then we're going to get a multiplier. That's going to give us our minimum lighting load. Then we're going to see if we have a demand factor we can take, and we'll have our lighting demand load. After that, we're going to get into our show window lighting, figure that up, and our track lighting, our sign and outline lighting. Then we'll get into our receptacle loads, get our demand factor for that, and we'll come up with a subtotal after adding all these cells together here. We'll slide that subtotal up here and start this new column. Then we'll get into our other loads that we find pointed out in 220.14 A through E and K through M. We'll list all those with their values. Then we'll figure up our kitchen equipment, get a demand factor for that, and come up with our kitchen equipment demand. Then we'll take a look at our heating and our cooling. We'll get into non-coincident loads and see if we have any of those, and we'll take the largest of those loads. Then we'll take our largest motor of the building, take 25% of that. Then we're going to add all of our loads together and come up with a total building VA. After that, we can divide by our voltage and we have our service amps. Okay, let's get to our example. All right, we have an office building here, 8,000 square feet. We got some track lighting, some power poles feeding some cubicles. We got general receptacle loads. We got some exhaust fans, rooftop heating unit, air conditioning unit, some hand dryers, copier station, some window shades, building sign. Then it tells us our voltage and the phasing of our service, and then we have to figure the total calculated service load. All right, you see our example data over here. We're going to start over here in the left-hand column, square footage of the building. So we have 8,000 square feet in our office building, and so we're going to put 8,000 right there. Then we're going to go for our multiplier, and we're told to go to table 220.12 to find our multiplier. Here in 220.12, we got our occupancy types listed over here. So if we go down to office, right there, it tells us we have a 1.3 VA per square foot multiplier. So we'll put 1.3 here, multiply 8,000 by 1.3, and we get 10,400 VA for our minimum lighting load. Next, we find out if we have a demand factor we can apply to that minimum lighting load. So we go to table 220.42 over here. Go down our left column, type of occupancy. Let's see, it's not a dwelling unit, not a hotel, motel, or apartment. It's not a warehouse. So our office building is going to fall in the all others category, and it has a demand factor of 100%. So we don't get any demand break for an office. So 100% goes here, and 100% of 10,400 is 10,400. Okay, moving on to our show window lighting. We have no show window called out in the office building, so we don't have to worry about that. We'll put a 0 there. Next up is track lighting. We do have some track lighting. We have 10 4-foot sections of track lighting, so we got to figure out how to calculate that. 220.43b tells us 150 VA per 2 foot of track. So we're going to take number of tracks. We have 10. Feet per track, 4 feet per track. Total length of track is 40, 10 times 4. So then we got to take the number of 2-foot sections because we're doing this per 2 foot of track. And that gives us 20 because that's half of 40. Then we multiply by 150 VA. So 20 times 150. And then times 1.25 because we have to take that extra 25% because this is lighting that is a continuous load, which means it'll be on for 3 hours or more at a time. we got to add that extra 25%. And that gives us a total of 3750. 3750 VA right there. All right, next up is our sign and outline lighting. We have a 600 watt building sign. However, over in 600.5A, we are told that we are required to have one circuit minimum at 20 amps, and then in 220.14F, we're told that that circuit must be at least 1200 watts. So even though we have a 600 watt building sign, we have to account for 1200 watts worth of power for this circuit in our calculation. And we have to add that 25% again for continuous load, so that's going to give us 1500 VA. Now we're going to move on to reciprocal loads. And we have 8 power poles serving 4 cubicles each, 4 receptacles per cubicle. All right, so we have power poles, 8. We have 4 cubicles per power pole, and we have 4 receptacles per cubicle. We're told in 220.14I that we are to apply 90 VA to each receptacle in any piece of equipment that has 4 or more receptacles. So 8 times 4 times 4 times 90 comes out to 11,520 VA. Okay, but we also have some general receptacles. We have 65 of them. So we're going to go down to this little table here, and in 220.14I also it tells us that regular receptacles are worthy of 180 VA apiece. So we have 65 times 180 gives us 11,700. So then we just add these two together, 11,520 and 11,700, and we get 23,220 VA. That's our total reciprocal load. Then we can go to table 220.44 right here to find out if we can apply a demand factor. So this is demand factors for non-dwelling reciprocal loads. It says the first 10,000 kVA or less at 100%. So we're going to take the first 10,000 at 100%, right there. And then the remainder over 10,000, we take it 50%. So we're going to take the remainder, 13,220, at half value, and that's 6610. Once we have that number, we're going to add all these bolded numbers together: the lighting demand load, the track lighting, sign and outline lighting, and then our reciprocal loads. Then we get 32,260 VA. Okay, we're going to slide that number right up here to this column. And then we're going to get into our other loads. And these are only as they apply, because not every calculation will have these loads. But these are from 220.14 A through E and K through M. These are basically all our loads that don't fit into any other categories in our calculation. So we have a couple of air conditioning units, but instead of putting them here, we're going to list them down here under cooling. So we have 2 8 kW air conditioning units. So that's 16,000 watts for both of them. We're going to list that down here because we're going to end up comparing that to the heating later. Okay, we have 2 1600 watt hand dryers, so 3200 VA, so 3200 VA for those. We have 4 400 watt copier printer stations, so we have 1600 VA for those. And we have 7 80 watt motorized window shades. So 80 times 7 is 560 VA for the shades. Now one thing to note, we have 2 1/10 horsepower exhaust fans also, but it tells us that they're on the general lighting circuits. We are told in 220.12 up here when we're dealing with our minimum lighting load that if we have any motors that are less than 1/8 horsepower and on the general lighting circuits, then they will be included in this figure here. So we don't have to worry about adding those into our calculation anywhere else. They are already taken care of. However, if they had not been on the general lighting circuits, if they like each had their own circuit, they would have to be accounted in the other loads category. So next we would take our kitchen equipment, but we don't have any in an office building, so we just put zeros for this value. So we'll go right on to our heating. And 220.51 tells us we take our heating at 100%, and we have 2 15 kW rooftop heating units. So that's 30,000 watts right there. We already have our cooling from before underneath it. And so now we're going to take our non-coincident loads Any loads that don't operate at the same time or are unlikely to operate at the same time, we only have to take the larger of the two. So of these two, because they don't operate at the same time, we just take the heating, 30,000 VA right there. And finally, we take our largest motor. So we have to go through our whole calculation, our entire building, and find out what our largest motor is. Well, in this case, our largest motor is the AC. But it's only one AC, so it's an 8,000 watt air conditioner. We take 25% of that 8,000, that gives us 2,000, and we'll put that value right there. So now that we have all these bolded loads filled out, we've got our subtotal from the other column, we've got our other loads, we've got our largest of the non-coincident loads, and we have our largest motor, 25%. So we're going to add all those up and we get a total building VA of 69,620. We know that our service is 208 volt, 3-phase. So we divide by our voltage and we get 193 amps. And that is our service size. And so here you have the entire calculation on one page. So in one shot you can see everything, including all the data from the example, and every step along the way you got your code references and you have a total. So you have everything in one shot. And what I did here is I gave you a template. I took the color or most of the color out of it so that you could screenshot it, you can print it, you can use it as a study guide, for practice, for a test maybe, a state exam perhaps. You can make multiple copies of this and use it for jobs, whatever you want to do with this, have at it. Okay, so thanks for watching, guys. If you thought this was helpful, please give me a like, and also please subscribe to my channel. That'll help push this out so more people can see it, other folks that may be looking for some help on their calculations. Let me know if there's anything else you'd like to see a video on regarding electrical and particularly calculations, and I'll see what I can do to whip one up. Please check out my other videos. I have a lot of calculation videos on my channel. All right, thanks again, guys, but don't forget, stay free.